last class yesterday, we had derived both the equations, common potential also, loss of energy also. So with the help of question only, let us revise what was the formula. One question we'll discuss, then we'll move on to series and parallel combination of capacitors. One instruction for all of you to open up your cameras for the class. Meeting, I have started the meeting on focus mode. So you'll not be able to see each other's video and it will also not be recorded. All right, only I'll be able to see, the host will be able to see you. So please switch on your cameras. And Fiaz, you have informed, Fiaz will not be able to. But from the next class, please make the arrangements. And yes, for this class, you all have to open up the video cameras. Now, it says that capacitor of 10 picofarad charged to potential difference of 20 volt is connected to an identical but uncharged capacitor C2. See what is meant by this. You have to find out common potential. You have to find out the loss in energy on sharing. What is C1? That is given as 10 picofarad, which is 10 into 10 to the power minus 12 farad. 1 pico means 10 to the power minus 12. Whenever pico term is written, 10 to the power minus 12. Okay. Now it is saying the second capacitor is uncharged, but it's identical. What is the question giving the hint to you? When it is saying the capacitor is identical, means value of capacitance is same. Okay, value of capacitance is same. So C2 is also 10 picofarad. That is 10 into 10 to the power minus 12 farad. 10 picofarad, 10 into 10 to the power minus 12 farad, right? Now coming to voltages. V1 is given to you as 20 volt. Yes, V1 is given to you as 20 volt. When we're talking about V2, we have no information about V2. So how will we write it? See, the way information about C2 was given identical, you will find that it is uncharged. If it is uncharged, there is no potential on it. So V2 is 0. Okay. Now coming to the formula of it. Coming to the formula. Again, I'm repeating the instructions for the students who have joined late. You all have to open up your videos, switch on your cameras for the class. All right, this is this is not just for the rest of the class, for this class also, all of you. Okay, it's already on focus mode, so you will not be able to see each other. It's just that, and one more thing, you will also not be recorded. Only my video will be recorded, yours video will not be recorded. Okay, yes, so common potentials formula which we discussed. Common potentials formula which we have discussed in the last class. Only Sidra is following the instructions. C1 V1 plus C2 V2 divided by C1 plus C2. C1 V1 plus C2 V2 divided by C1 plus C2. This was the formula of common potential. So by this we have revised it also, and you should know how to apply this. All right. Now see C1, what is the value? 10 into 10 to the power minus 12. Into V1 is 20 plus C class. This is 10 into 10 to the power minus 12. V2 is 0. Divided by 10 into 10 to the power minus 12 plus 10 into 10 to the power minus 12. So this term becomes 0. So you actually have 10 to the power minus 11 into 20. And this becomes 2 into 10 to the power minus 11. So this will be cancelled. This is 10. So 10 volt is the common potential. All right, but do make the arrangement. So, okay, Rajita, for this class, I can understand you were not informed. But for the rest of the classes, please make an arrangement. Not only Rajita, rest of the students also. Yes, second part was loss of energy. So this was the formula which we had discussed in the last class. C1 into C2 multiplied by V1 minus V2 whole square divided by C1 plus C2. This is the formula which we discussed. Okay. Now let us put it in here. Second part, delta U is C1 into C2 V1 minus V2 whole square divided by 2 into C1 plus C2. So C1 is 10 to the power minus 11, C2 is 10 to the power minus 11. V1 was 20, V2 was 0. 2 into, again, this becomes 10 to the power minus 11 plus 10 to the power minus 11. So this becomes 400 into 10 to the power minus 22. This is again 2 into 10 to the power 11 into 2. So this becomes 4, that becomes 100. So 10 to the power 2 minus 22 plus 11, 9, minus 9. So this is 10 to the power minus 9. That's the answer. All right, so formula based question it is, it's a revision. Now we'll start with series and parallel combination of the circuits. Note down the question first, write down the solution. Any doubts you have, let me. See class, this is a portion that comes in your exam. We have discussed capacitors, parallel plate capacitors. We have already discussed it. See, there's a question which comes when the plate is connected or means the battery is basically connected or disconnected. So there are certain changes that occur. You can just note it down later. First, understand it. This is not difficult, but it comes a lot. It has been repeating itself so many times. Even when you will be solving questions, you will search connected and disconnected word is mentioned. So this was what we have studied. C is equal to epsilon naught A by D. Charge is C into V. Potential difference is V. And using the formula of potential gradient, we have seen E is equal to V by D. Now see, if what are all the changes that will occur if the battery is connected to a dielectric constant and battery is connected. Battery is connected. So capacitance will become K times, right? Dielectric constant will be multiplied. So capacitance will become K times. As a conclusion, capacitance increases. In your MCQs also, this is very important. And this topic, no, this is actually a very important topic from your class 12 perspective, especially from this lesson. Something that has to come exclusively from this includes this battery connected and disconnected portion. All right, now charge is CV. Remember, potential will remain same when the battery is connected and charge will remain the same when battery is disconnected. Disconnected we'll see later. First, let us focus on connected. So battery is connected, charge is increasing, capacitance is increasing, but potential difference is remaining constant. Now, if potential remains constant, potential difference, this will remain constant. So this will also be constant because this is actually ultimately consisting of V naught only. So E is equal to V naught by D. This is remaining constant. Please remember these brackets also. All right. K times it is increasing. So capacitance is increasing. Charge, what is happening to the charge? Charge is also increasing, but potential remains the same. Now coming to when the battery is disconnected. See, when the battery is disconnected, dielectric slab is placed. See, capacitance will be increasing. Why capacitance will be increasing? Because you are already having capacitance value for conductor, so that will increase. Now, when we are talking about charge, I have told you for charges will remain constant when we are talking about battery disconnected. Battery connected, potential was same. Battery disconnected, charge is same. Please remember this line. Capacitance will increase in both of them. Charge and potential, if you remember, electric field will be as it is what is happening to potential. C will be K epsilon naught A by D. That is K times it is increasing, right? And charge is equal to Q naught. That is, it is remaining constant. Potential, because it is decreasing by K times. I think in your test also this came. Charge decreasing. No, your batch didn't have the test, no? So yes, potential will decrease K times. And since potential is decreasing, getting decreased by K times, you will have electric field also getting decreased by K times. So not only remember the formula, remember these brackets also, that whether something is one quantity is increasing or one quantity is decreasing, like this, remember it. All right. This I'll tell later. First note it down. Note down this part. Parallel plate capacitors. Now, class, when we are discussing regarding series and parallel combination, see, we will be paying attention over here. That is same applicable when we are studying resistors. All right. So many students have joined right now. Again, I'll repeat the instructions. From now onwards, you have to open up the cameras. Switch on your cameras. Switch on the videos when you are studying. Mariam, your video is on, but it's blank. Please check the camera once again, Mariam. All right, class. Now see, coming to division of charges and voltage. Just remember this. This is helpful not only for your resistors, not only for your capacitors, but throughout you have alternating current also. Every time you will be using series and parallel combination. See, when we are using, yes, Mariam, I think some issues are there. Please check. See, when we are talking about division of charge means whenever there will be a branching in your circuit, your charges will divide. Just focus it till here. This is not important. Whenever branching is there, suppose there is one single wire. Suppose this is one single wire that I have. Fine, I'm having this single wire. Now some charge is flowing through this. Some charge is flowing. I have turned it like this. So the same amount of charge will flow through it, even if I have turned. So turning or just bending of the wire does not change your charge. All right. That won't change your charge, even if you have turned it in the form of L shape or it is still in the form of I. Whenever you are having, when you have branched, it means one more wire has been added, one more wire has been tied up, current or charge, both of them will divide. Current we'll use in current electricity, charge we'll use in capacitance. Pay attention to both of them. Charge or current will not divide unless and until branching is there in your circuit. One example, look at this example. Look at this. Charge Q is coming. For example, 5 coulomb of charge Q. This is 5 coulomb of charge which has come. Now this 5 coulomb of charge, this is coming. And here there is a junction. This is the junction which is dividing the wires into two components. Fine. The charge is dividing the wires into two components. Now what will happen? Equally, unequally, depending upon the voltage and rest of the factors, the charges will divide themselves. All right. Now, if we have connected one device, let's say a capacitor was connected. So capacitor won't change it. For example, this means if this is the charge, one capacitor is connected. 3 coulomb is flowing here. So still here, over here also, Q1 will be the same. 3 coulomb of charge will only be flowing. Your charge will get divided unless and until there is a presence of branching. Otherwise, it won't divide. It will keep on flowing, whether you bend it or not. Charge divides due to branching. Like this. See, Q is coming, capacitor C1 is there. All right, Q is coming, C1 is there. This is the charge. Device didn't disrupt it. All right, now charge came at this junction. So branching occurs. So it divided itself in the form of Q1 and Q2. It can be equal also. Q1 and Q2 both can be equal. They can be unequal also. Now Q1 was flowing, one device came, C2. Nothing happens to the charge. So Q1 will remain as it is. Q2 is coming, C3 is there, one more capacitor is there, nothing is happening, charge is there. Same goes for current and resistors. If current is coming, resistor is there, nothing will occur, but as soon as branching or junction is there, current will divide itself. Coming to voltages. See, what are the device when I'm using the term? First device is a capacitor, second can be a resistor, third can be inductors. These devices we have not discussed till now, these can be used anywhere. Now, whenever there is a device in your system, now voltage will divide. Why are we learning these basics? Because you have to ultimately identify series and parallel combination from your resistors. Then only you'll be able to apply the formula. Formula part is very simple. Derivation also is usually not asked in your exam, the derivation of C equivalent or R equivalent. All right. So a device is there. All the three devices are there. If we are having capacitor, if you are having a parallel plate capacitor, so potential on either sides will be different. If you are having a resistor, potential on either sides will be different. Fine. Potential will be different on either sides. Now see, this is the case. A is there, potential is there, till here it is VA. Capacitor came, a device came in your circuit, potential changes. Branching doesn't affect your voltage. It's VB here, it will be VB here also. It's VB here, it will be VB here also. Now again device came, so it will change, it becomes VC. Here it was coming VB, device came, so it will become VB. So this didn't affect it. See, VB was here. But this will affect it. All right, so this is how you have to first identify which quantity is getting same, which quantity is getting divided. Then only on the basis of it, you will identify series and parallel. How on the basis of it, you will identify series and parallel? When the potential will remain same, then it means all the devices are connected in parallel. If charge remains same or current remains same, then it is series. This I'll discuss. First, write this down. These are the basics for your DC circuits. You will have questions. Done, class. Now see how to identify series and parallel. I have told you series will be when the charges remain the same. This you have to remember, when the charges remain the same. Charges will be the same. It means you are having series combination. All right. Now, how to derive it? Derivation is just in one line. Don't worry about the derivation part. Derivation part is very easy. What you have to remember is that you have to identify the charges first. All right. Once you have identified the charges, then it's very easy. See, charges are remaining the same. So what is the difference? Potentials are different, right? V is equal to V1 plus V2 plus V3 plus V4 till Vn, right? So how can you write voltage? Voltage can be written as Q is equal to CV. So voltage can be written as Q divided by C. This is what is voltage can be written as. Now capacitances are different, but charges are same. So V will be Q by C equivalent. V1 will be Q by C1. V2 will be Q by C2. Likewise, it will go for all the values of capacitors which are connected. If there are two capacitors in your circuit, only C1 and C2. If three, so C1, C2, C3. Nth, so we have taken it till nth. So in series combination, the final equation is 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C3 up till C nth. Now, if I want to find out the net charge for the overall circuit, see, individual charges are something else, right? But in this case, when we are talking about series connection, the individual charges or the total charges of the circuit, all are same, right? Because charge is the quantity that is passing same through all the capacitors. So overall charge is equal to the individual charge. If Q is equal to C equivalent V for the entire circuit, entire resultant, still for individual circuits, we'll use Q only, right? Why Q only? Because this is the answer. This is the value of the circuit and it is remaining the same for series. But when we're talking about potential, it will become Q by C1 for each. There will be a net potential that is connected in the battery. That value you will be seeing, that you can calculate. Using this, you can calculate net voltage. But individual voltages will be different. V1 will be Q by C1, V2 will be Q by C2, like this. All right, so voltages will be different. Then coming to energy, similarly, energy will also be half C1 V1 square for individual. And when you want to find out that energy for the total entire one, so you total use C equivalent. C equivalent will be for the total. When you use individual capacitors, that will be C1, C2, C3, like this. So you can use C half CV square also formula. You can use half Q square by 2C formula also. Note down this portion, division of voltage. Yes, class. So these are the individual capacitors formula. Fine. Energy also you have it in different capacitors also. So energy, voltage, power, current, everything you have to remember. Not current. Current I'm relating to resistor. Charge for this specifically you have to remember. Coming to parallel connection. The questions I'll discuss later. Parallel combination, potential will now remain the same. Now the charges are different. Why? Because branching has occurred. And once branching has occurred, individual charges will be different across every wire, right? So potential is the same. And if you see anywhere, no potential is becoming same, then directly calculate it as parallel combination. So now if charges are different, we'll be using charges formula. That is, we'll add all the charges. Total charge will be Q1 plus Q2 plus Q3 plus Q4 up till Qnth. Now, what is Q formula? Charges formula. Q is equal to CV. So total charge will be C equivalent into voltage. Individual capacitors, when we are talking about individual capacitors, C1V, C2V, C3V, C4V, like this. V will remain the same. It's like common potential. Common potential we had seen yesterday. So it's like common potential. Potential is remaining the same. But capacitances values are different. So you directly add it. So conclusion is that for parallel combination of capacitors, you algebraically add all the capacitors. All right, for parallel combination. And for series combination, you have to reciprocally add all the capacitors. All right, reciprocal addition of capacitors you have to do for that. And similarly, once you are having parallel combination, also same things you will use for parallel combination. It's just that V will remain the same, charge will be different, capacitance will be different. All right, note down this also. Mariam, see, potential, all these values, these are getting cut because these are same. If you take this V common from here, and V is already here, so V will get cancelled. Ultimately, you will left. See, just take V common from here. What are you left with? C1 plus C2 plus C3 till V Cn. So V from here and V from here, they'll get divided. That's why. Because it is same in this. Is it on now? It's clear, no? Okay, fine. See, I was saying when we are having, you are having three capacitors over here, 10 microfarad, 5 microfarad, 10 microfarad. So you have to identify whether all of them are connected in series, all of them are connected in parallel, or it's a mixed combination, some in series, some in parallel. Fine. So like this, you are having three capacitors. So what we'll do, if we look here, some charges flowing through here, charges flowing. See, when the charge, let me write it, some charge is flowing. When the charge is coming here, it will not change. Now, but when the charge will come here, charge will divide because of branching. It means they are connected in parallel. Let me name them. This is 1, this is 2, this is 3. 1 and 2, they are connected in parallel. And in capacitors, for the parallel combination, we simply add it. So C12 will be C1 plus C2. That is 5 plus 10, which is 15 microfarad. Now class, if I have this 10 microfarad was there, now I have made that reduced to 15 microfarad. Now this is 15 microfarad. Instead of the both the wires, no, which were connected, both of the wires, we have connected one common 15 microfarad. This is one common 15 microfarad. And now 10 microfarad was already there. Now what we can see? See, first go step by step. We have reduced 1 and 2. When we reduced 1 and 2, we obtained 15 microfarad. Then 15 microfarad with 10 microfarad. They are connected in series now. Look, this is now C12 and this was C3. You can see 1, 2 and 3. C12 and C3, they are connected in series. So what is the formula of series we have seen? They get reciprocally added. Means the entire C equivalent will be 1 by C12 plus 1 by C3. So this will be 1 by 10 plus 1 by 15. That's it how you have to solve. 1 by 10 plus 1 by 15. Now you have to reciprocally add it. Or the best way is that you can write 10 into 15 divided by 10 plus 15. This is the way which you can write. So this directly becomes 15. This becomes 150. This becomes 25. Further, if you want, you can solve this also. You have to actually simplify the answer, final answer which you write. This becomes 30. That is 6 microfarad is the answer. Fine. So series and parallel combinations have to be solved like this. Note down this. Class, note down this question. At least try this once by yourself. Then I'll discuss it right now, but at least you people should try it once. How much you're getting, Mariam? 2C. Okay. Anyone else? Only Mariam has tried and solved it. See, class, one hint, no, whenever you have circuits in your question and it's given an equivalent resistant or equivalent capacitance between A and B, equivalent resistance or equivalent capacitance, it says between these two. It means it is basically telling you that there's a battery connected. Like this. This is a battery that is connected, that completes your circuit. So whenever now you will have your capacitors, voltages, and it will be asking you whether it's between A and B. Like this only you have to put. Okay. Now let's name the resistors. See, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Now I'll start from this extreme and look here, class. Look at this. There is a branching at this junction. It means both of them are connected in series or parallel. 1 and 2, are they connected in series or parallel? At least this you can all tell me. All of you can tell me. Parallel. Very good, Mariam and Amna. It's parallel. So 1 and 2, they are parallel. And if two capacitors are connected in parallel, their net resultant capacitance is by directly addition of it. So C12 will be C1 plus C2, that is C plus C, which is equal to 2C. So here, instead of writing C12, we can replace it as 2C, right? Now class, this tell me, series or parallel? All of you should answer. Deborah, Fadil, Sidra, Rajata, at least this you people can answer series or parallel. Series, very good, series, because the wire has just been bent, right? So if this is connected in series, it means C3 and C12, they are connected in series. So we have to find out their resultant. This means 1 by C123. I'm just writing C12, C123 to indicate that this is a summation of all these, right? So C123 will be 1 by C plus 1 by 2C. LCM will be 2C. This will become 2 plus 1. That is 3 by 2C. So C123 will be 2C by 3 micro. No, nothing was given. No? 2C by 3. Now, class, one thing. Do not forget to reciprocate it. Many students have a habit of leaving their answers like this. Even today, I was checking some papers of other batches. There also, they have done the same thing. 3 by 2C like this, reciprocate it. All right, denominator and numerator should be exchanged because our formula is 1 by C equivalent and we require C equivalent. Now, instead of writing both of them together, I can write it as like this. 1, 1, 2, 3, all of them have been together written as C123. And this C123 can be written as 2C by 3. This is C, this is C, this is C. Now, look at this. Series or parallel? Fadil, you have still not answered. Other students also, Rajita, Deborah, series or parallel? Amna, Aliza, correct? Yes, series or parallel. This type, we have started with this only. It's parallel connection, class. Yes, Fadil, it's parallel. Good, Deborah. Because see, branching is there. Right, parallel connection. So it means C123 and C4, they are connected in parallel. So for parallel connections, for C123 4 entire, we just added. So 2C by 3 plus C, this will become. So this is C, 5C, right? 5C by 3. Now finally we are left with 5C by 3, C and C. Ultimately we are left with these three. We are left with these three. So now all these three are connected in series or parallel. Wire has been bent, series or parallel, because this is the final answer. This is our last step in the calculation. Aliza, right. Sidra, correct. Amna, correct. Right, Deborah? Yes, other students also. Series or parallel. Mariam, Fia, Fadil. Correct. Series combination. It's just a single straight wire. Series combination. So 1 by final C equivalent will be 1 by C plus 1 by C plus 3 by 5C. So it's 5C over here. This becomes 5 plus 5 plus 3. That is 13 by 5C. This is 1 by C equivalent is 13 by 5C. So final answer, that is C equivalent, will be 5C divided by 13. So this is our final answer. Note it down. Any doubts if you have at any step, let me know.